Hi everybody, this is Mrs. Ellsworth. Do you remember a while back we talked about making Bohr models? And so we would go and look at a certain element on the periodic table, like this one under here. You can't see this, but it reads 35.453. And so what we would do is we would round this number and come up with the mass number. Okay, and then also the 17 was just the number of protons that the whole periodic table is arranged by its atomic number. So we would go and take this average, we would go and round it. We round down because it's a 4. If it was a 5 or more, then we round up, but it's not. Anyway, so then we would get this lovely symbol right here with chlorine having a 17 and a 35. So let's go ahead and look at what the Bohr model would look like, and I've already got that printed out for us here. And so you can take notes on this and catch up if you'd like, because what we're going to talk about is isotopes right now. Isotopes. Okay, so isotope. Okay, an isotope is, and you need to write this down, an isotope is just an atom with a different number of neutrons than what we expect. Okay, we always expect there to be an atomic mass of 35, so we'd have 18 neutrons. Well, once in a while there are some that have got a different number of neutrons. So let me go and show you that. How do I even show what an isotope would be? I mean, is it called chlorine? No. An isotope, let me get this out of the way. An isotope is chlorine number 35. Okay, so that means that 35 is this one. Remember, this is an average, so there are others out there. It's just that most of them are around 35, or else the average wouldn't be close to 35. Like, for example, there is chlorine 37. So let's just go and look at, well, what do I mean by that? Okay, so this isotope is chlorine 35, chlorine 37. Now, if I ask you for a Bohr model of chlorine, we're going to just do the regular old way that we've always been doing it. But if I ask you, well, what are these two things, chlorine 35 and chlorine 37, you'd say, well, they're isotopes of chlorine. But let me also go and show you that definition that said that there's a different number of neutrons in it. Let me go and show you what I mean. Just a little bit of backstory on it. I won't ask you to do this. Anyway, so with chlorine 37, we now have a different mass number. And so instead of this chlorine 35, it would have a chlorine 37 right here. And so we would go and take, and we know that we'd have the same number of protons, same numbers of electrons, because this an isotope means it's got a different number of neutrons. So we would go and subtract, remember there'd be a 37 here and a 17, and we would get 20 neutrons. So the only thing that is different in this atom or isotope of chlorine is the 20 neutrons. That's it. It's just a heavier element of chlorine. Heavier atom of chlorine. Okay, so just a reminder that these guys are here are neutral, and because they got the same number of protons and electrons, but they have a different number of neutrons, which is the definition of a isotope. Okay, now I need to talk about the second thing that we're going to talk about, and that is an ion. Gee, I just switched to the wrong page here. Okay, so here we go, an ion. So let's go and look at another atom, oxygen. Okay, it's 8 and 16. Okay, and so we're going to talk about ions here in just one moment, but I sure want to talk about an atom of oxygen first. Okay, so we've got 8 protons and neutrons in the center. Okay, and then we've got 8 electrons, so that goes 2 electrons and then 6 electrons for a total of 8. And don't forget, you can always double check your work by counting over, and that'd be 6 over here, and so that you could always double check that, because it's the second row on the periodic table and it has got 6 electrons going across. Okay, so there are other things too called ions, and let me go and type. So an ion, okay, not an isotope now, we're on something else, the second subject. An ion is an atom that has lost or gained electrons. Okay, now you might think, well, Mrs. Ellsworth, can they do both? Yes, they can, but I'm going to keep it simple, and we're going to separate the two whenever I talk about them. Now you know that before that when you went and identified an isotope, it would have this number behind it, right? Well, an ion is very different because now if it's lost or gained electrons, it's charged. Okay, so it's got to have a charge on it. So this right here is oxygen, but if I was going to talk about the oxygen ion, it'd be O to the -2. Now it's going to show a charge. Because it's lost or gained electrons, it's going to show that it's got a charge. Okay, so let me get that out of there and let's talk about lithium. Oh, I guess it's not leaving. Anyway, so here's the lithium atom. Okay, and so what happens with lithium is that it goes and it loses an electron. Okay, and you don't need to know about that particular, but I want you to know now that when it loses its electron, it's now going to have a +1 charge. We don't have to figure that out, but we have to realize, what does it look like? So that's not going to be lithium ion, and so lithium ion will have this +1 charge on it. Okay, so what is an atom? Okay, here's lithium. The atom is got a neutral charge on it. Okay, it's the smallest building block, and it's got of all matter, and it is neutral. Okay, but an ion isn't. It's a charged atom. It's lost or gained electrons, and so we always show that with a plus or minus and then a number. I gotta tell you, in chemistry we're a little bit lazy. We don't ever write ones. Okay, so this isn't a +1 charge. It's just known as plus charge because we just don't write ones. Like I said, it's a little bit of laziness going on. So what would an ion look like? Well, here's a whole bunch of examples of ions. Okay, oxygen to the -2. Calcium would be to the +2, so that's a calcium ion because it's got that charge on it. Now chlorine is chloride now. We'll talk about that the next test that we take, that the chloride ion, how we name it. But anyways, a -1, it's got a -1. Again, we don't write ones. Fluorine is a -1, but we don't write a -1. Lithium ion, of course, I just mentioned that one is a +1, and same with sodium ion. We will learn about how to give those charges. I think it's 2 tests away, so we've still got lots to learn, and I just wanted you to be able to identify an ion, okay, with that charge written on it. So like again, here's lithium and lithium ion. And then I wanted you also to be able to identify, oh, oopsie, what an isotope looks like too. So this is our small little lesson on ions and isotopes. I will see you later.